Good afternoon. I'm Galileo Sartor, and I've been working for the University of Torino in collaboration with the University of Bologna on legal knowledge representation in the domain of private international law. I'll briefly introduce the IFDaD project and then focus on the module in which our research is more present. The IFDaD project is an EU e-justice project that aims to build a set of tools to facilitate the access to internet-related private international law in an online platform. These three modules are the decision support module, find law module, and the training module. And they are, and of the three, the decision support module is the one in which our work has focused on. It is used to train lawyers and judges, or to help or to assist with navigating this complex field of law. In particular, we built a representation of some European regulations to automate the interpretation of the law. First of all, we identified some requirements, both legal and technical, that would become the basis of our representation. The legal requirements deal most of all with the structure of the original text, and the most important ones are isomorphism, so the one-to-one correspondence between the source text and the representation. Reification, which is the fact that we can have rules that only alter existing rules, so they don't say anything about the world as it is, but they can alter other rules, for example, with a time frame in which that rule is valid. Then we have the feasibility, so the ability to defeat a rule, even if that rule by itself would be satisfied. Finally, we have the issue of vague concepts. Often when we write a legal rule, we make some assumptions, for example, on the good faith of the people involved, or of what a reasonable delay is. Then the technical requirements deal most of all with the syntax, with how we chose to represent this knowledge base. This can vary depending on the different uses of the tool that we want to build. So we had to find a way to easily identify what an exception is. We had to lower the computational complexity, and we had to guarantee that the system would be able to some extent, explain what its results are and where they come from. In this representation, we focus mainly on three EU regulations: the Brussels regulation on jurisdiction, the Rome I regulation on the applicable law in contractual obligations, and the Rome II regulation in applicable law to non-contractual obligations. We chose a modular approach with each legal source represented independently, so represented technically in a different file, but the idea was to have every regulation be independent, so have it work on its own. This would enable the possible inclusions in the future, not only of different legislations in this field, but also to extend the system to different fields. The approach we took to the modeling is we started from the English version of the regulations. And from that, we extracted a sort of pseudocode. So we eliminated the less useful parts. And we focused on the concepts. That were then put together in an ontology. So we could figure out what were the important parts, what were the variables that would change from case to case. And on top of this, we built structural elements, so predicates or rules that were only useful internally to the system. We decided to deal with defeasibility with negation by failure, which is the property of logical programming, where if a condition is not satisfied, it is then negated. So if a fact that says that that is true is not contained in the knowledge base, then it is considered as false. And then we built an interpreter to build a proof tree to show what articles were used in the representation to arrive at a certain conclusion. This would solve the issue of the explainability or justification. Here we have an example of how this system could be used. Granted that in the future it would be possible to add a graphical user interface to simplify things further. But we have, for instance, two persons, one natural and one legal. They have a contract for provision of services in certain cities, Vienna and Paris. The services are not provided, so the natural person, Sylvia, refuses to pay the fee. Woodfloor then decides to sue. So in this case, what we have to do is tell all these facts to the system. So who are the parties involved, what type of contract they have, where they live, or where they have the place of provision. And then we can ask the system where the jurisdiction is for this claim, for this particular claim. The system will then give us all the possible answers. So the possible answers are Luxembourg, France, and Austria. The first one because it is the domicile of the defendant, and the other two because they're the places where the services were supposed to be provided. For each one of these, we have our explanation. So our solution is extracted from a certain subset of these facts. In this case, it uses the one of the first articles of the Brussels regulation, looking at the domicile of the defendant, and if that domicile is in a member state, then it is true that that domicile is also a possible place for a jurisdiction of the claim. This system is very useful. It can help in decision making. It can help judges, lawyers, private citizens, students. And we're testing it now with judges, and results are encouraging. And we purposely built a model that could be easily extended, adapted to other legal domains, deal with certain issues of description of concepts or of difficult terms that may not be as easy to explain. And this is also one advantage, because if we were to change a rule, change a law, we could also test it in the system and see what possible errors could come up, or what incompatibilities would surface from any future change. So this is where we are now, and thank you for listening to me. And if there's any questions, I'm glad to answer as best as I can.